After Michael Faraday discovered electromagnetic induction, one of the things he invented was the transformer. Pictured here is that first transformer that he built. A transformer consists of a primary set of windings and a secondary set of windings around a common magnetic iron core. The magnetic flux produced in the primary gets funneled into the secondary. We will define the magnetic flux in the primary as pointing up and the magnetic flux in the secondary as pointing up. So psi sub p is equal to minus psi sub s. So let's apply Faraday's law to our primary circuit. Assume very high conductivity for the wire making up the primary, so the integral of E dot dl through the wires will be negligible. So the integral of E dot dl on the primary will just be minus V sub p. So V sub p is equal to the number of turns in the primary times the change in magnetic flux with respect to time in the primary. Now applying Faraday's law to the secondary, on the left-hand side we'll just have V sub s, and on the right-hand side we will substitute for psi sub s minus psi sub p. So the voltage in the secondary equals the number of turns in the secondary times the rate of change of the magnetic flux in the primary with respect to time. So dividing this equation by this equation, we see the ratio of the voltage in the primary to the secondary equals the ratio in the number of turns in the primary to the number of turns in the secondary. The power into the transformer is going to equal the power out of the transformer. So the ratios of the currents in the primary and secondary of the transformer become IP over IS is equal to the number of turns in the secondary over the number of turns in the primary. So by whatever factor you step up the voltage from the primary to the secondary, you step down the current from the primary to the secondary. The war of the currents involved how electrical power was going to be distributed. Was it going to be distributed by DC or by AC? And the transformer played an important role. Nikola Tesla grew up in Serbia, and he was educated as an electrical engineer. And he went to work for the Edison Company in France and eventually moved to the U.S. to work directly with Thomas Edison. Edison was developing electrical power distribution systems based on DC. Edison told Tesla that if he improved the efficiency of the DC dynamo, the device for generating DC electricity, he would give him $50,000. Tesla got the dynamo to the efficiency that Edison asked for, and then asked for his $50,000. Edison's response was, "You don't understand American humor. I was joking." So Tesla quit, and he had difficulty finding employment. For a while, he was employed digging ditches. So back then, you'd have to manually dig ditches for laying pipes in cities. Eventually, George Westinghouse hired Tesla, and they started to develop an AC power distribution system. Edison's DC power distribution system had limited range because of the I squared R losses in the wires carrying the electrical power. With transformers, Westinghouse and Tesla could step up the voltage and step down the current, thereby greatly reducing the I squared R losses in the wires carrying their AC power. So they could distribute their AC power over much greater distances than Edison could do with his DC power. Then at the point of use, they could use transformers to now step down the voltage. With this advantage, the AC system became the accepted method for power distribution.